Welcome to this video on the Impossible Bridge, the world's highest railway bridge, conquering the Himalayas. We will explore how engineers built this massive structure in one of Earth's most unforgiving environments. The goal was to connect the geographically isolated Kashmir Valley. The 169-mile all-weather rail line provides economic connection and strategic access. This ambitious project required 943 bridges and 36 tunnels to cut through the Himalayas. The environment posed extreme difficulties. The terrain was unstable. The climate varied from -10 to +50 degrees Celsius, and there was zero initial infrastructure. Engineers initially accessed the site by foot or boat. Challenge 1 was the logistics of isolation, moving 30,000 tons of steel without roads. The solution was terraforming. This involved constructing 26 kilometers of new access roads and building an entire fabrication ecosystem on site for prefab components. Challenge 2 was the Venturi effect. The canyon acted as a giant funnel, causing chaotic acceleration and wind gusts up to 165 miles per hour. Computational fluid dynamics was used to predict localized speed boosts and secure the structure. Challenge 3 was tectonic instability. The bridge is in a high seismic zone where the Indian and Eurasian plates collide. Engineers leveraged the massive scale of the structure, meaning the ground movement had a low relative impact. The design solution involved locking the V-shape using an arch. Vertical towers were too risky on unstable slopes. The arch converts vertical weight into compressive force, driving it into the mountain rock and mechanically locking the structure in place. Construction was an aerial trapeze, building without ground support. A massive cable crane, a monorail of cables, was used to winch steel segments into position. Temporary backstay cables stabilized the arch as it was built from the bottom up. The logistics used a, quote, flat pack strategy, similar to the IKEA approach. Since transporting large, prefabricated sections was impossible, steel was transported as flat plates. All cutting, drilling, welding, and fabrication were performed on site. Installing the deck was achieved through the launch method. The challenge was placing the flat railway deck on the curved arch. The deck was built in sections on flat ground and incrementally pushed across the canyon, sliding on top of the arch until meeting in the middle. Challenge 4 involved thermal expansion. With temperatures hitting 50 degrees Celsius, the massive steel structure expands and contracts, causing the bridge to move daily. The solution involved pre-stressed rails and floating fixings that allow the tracks to slide freely. The scale of the bridge is immense. At 359 meters above the riverbed, the Chenab Bridge arch is taller than the Eiffel Tower. It used about 30,000 tons of steel and cost approximately $5 billion, part of a 169-mile line with nearly 1,000 structures. This project was a 20-year odyssey. Starting with site access in 2004, the arch installation was completed in 2017, the deck in 2022, and the inauguration in 2023. It truly was a monumental challenge. The inauguration in summer 2023 marks a new chapter for connection. The bridge provides a critical economic boost, proves Indian construction capability in extreme environments, and stands as a symbol of perseverance against nature. Where impossible becomes reality, construction crews battled heat, snow, wind, and isolation to build where no one had built before. Through determination and innovation, they successfully completed this extraordinary feat of engineering.